Hello, I am Hamid Arbey. I am a Microsoft MVP in Developer Technologies and Cloud Solution Architect. I am also Docker Captain. Uh, I will present today a session about optimizing .NET 8 applications with Docker and Azure. The session will be in English. So today we will delve into the exciting world of .NET 8 and explore how we can leverage Docker containers and Microsoft Azure to enhance the performance and scalability of your applications. In today's fast-paced digital landscape, businesses are constantly seeking ways to deliver applications that are not only efficient and scalable, but also agile and adaptable to changing market demands. And throughout this session, we will not cover we will try to cover the synergies between .NET 8, Docker containers, and the use of the cloud with Azure Container Services, providing you with a comprehensive guide to deploying and managing .NET 8 in Docker and locally in your local environment, development environment, and in Azure. It's your cloud environment where we will deploy your solution. So let's start with our agenda. So we'll talk in the beginning about an overview of .NET 8. Let's say what we cover, what we have, what's new in .NET 8. Next, an introduction to Docker containers. We see how we can integrate .NET 8 with Docker. We will use Visual Studio Code, and you are able to use also Visual Studio 2022. And next, we will try to see how we can deploy our application to Azure Container Services. So let's start by an overview of .NET 8. So the different features that was already presented during .NET Conf next November conference. So we let's summarize that in several key points. The first one is related to performance improvement because .NET 8 includes over 1,000 250 performance improvement, particularly related to JSON API scenarios and realist workload with database accesses. We have also ASP.NET Core enhancement because we offer extended capabilities for modern web application development, and we have also with enhancement tools for server side rendering and client side interactivity. Um, we have a lot of improvement related to Blazor, web assemblies. We have some features improved in server side rendering and increasing interactivity with WebAssembly components render. A, it's render faster, and the new web packaging features are introduced. We have more features in C Sharp 11, so because such as primary constructor and collection expression are added, improving code readability and simplicity. And for .NET 6, .NET 5, .NET 8, .NET 7, .NET 9 that is already in preview mode. We have always a development tools improvement inside Visual Studio Code, Visual Studio 2022, and they introduce a great development experience. It includes improvement for routing, debugging, and API testing. So we have always a lot of features that are added to these tools, Visual Studio and Visual Studio Code. We have also seen in the .NET Conf, next .NET Conf reference architected eShop that is really a great reference application to start with because it uses cloud native microservices architected and highlight the new capability of .NET 8, and we can find also containers, the use of Docker, how you can deploy, how you can get logs. So we have a lot of features in this reference architected. I recommend really highly to see the GitHub and the source code of this entire solution that include multiple applications, multiple projects, I recommend to take a look about it. And we have full stack application development because .NET 8 emphasizes ease of development for full stack web application with improvement for both the backend and the front end developers. Because security is really important, security, performance, enhancement, and we work always on improvement related to these important things, security and performance. And really, ASP.NET Core is designed with a focus on security and optimizes for performance, enabling efficient handling of various scenarios. We know that we can use .NET to deploy and develop mobile app development and for web application for cloud native also. So this is why .NET 8 continues to evolve as a preferred platform for cloud native and for any other mobile development. And we know that we have a great community based on .NET Foundation, for example, where you can find the different projects and contributions of the community, local community, MVPs, and anyone who'd like to contribute in a .NET. So .NET 8 has benefits from strong community contribution, and this reflected a growing and adoption impact in the world of software development. Now we already talked about .NET 8. I tried to focus just to generic, to summarize, let's say, the different features, different an overview about what's coming with .NET 8. And let's start now talking about containers and what is Docker, why we need to use Docker in this case, and how we use Docker with .NET 8. So what is containerization? Containerization is an approach to software development in which an application or service, its dependency, and its configuration, abstracted as deployed manifest files, for example, are packaged together as a container image. The containerized application can be tested as a unit and deployed as a container image instance to the host operating system, just as shipping containers allow goods to be transported by ship, train, or truck regardless of the cargo inside. So, software containers act as a standard unit of software deployment that can contain different code and dependency. Containerization software Containerization software this way enables you as a developer or IT professional to deploy them across different environments with a little or no modification because it's portable. So if you create your container internally, it's supposed to be working also in the same way without any modification in an other environment like a production environment, for example. And it comes to resolve this problem. I know that I was a developer. I know that sometimes it works in my machine, but it doesn't work when I try to deploy it in a pre-prod after production. Sometimes it works in pre-prod, so we try to do the different tests. It works, and in production we get some bugs, for example. And this is why it's a way where you deploy your application. It comes to resolve this problem for developers. And containerized application run on top of a container host that it's in turn runs on the operating system, for example, Linux or Windows. Containers therefore have a significantly smaller footprint than virtual machine images. So let's see how what is the architecture of Docker, what's going to include. So Docker is using a client server architecture, as you can see here. And the Docker client talks to the Docker daemon, which does the heavy lifting of building, running, and distributing your Docker containers. And the Docker client and daemon can run on the same way, in the same system. Or you can connect a Docker client to remote Docker daemon, for example. This can be a solution to secure your Docker daemon. So this is related to how we can secure our container and specifically the daemon, the Docker daemon in this case. So you are able to connect the client that is in your machine with the Docker daemon in it will be in another machine remotely. And Docker client and daemon communicate using REST API over Unix sockets or a network interface. Another Docker client is Docker Compose that lets you work with application consisting of a set of containers. Let's suppose that we have a UI application, ASP.NET application, and in the same solution we need to consume a database that will be containerized also. So in this case you have two containers, so you need to use Docker Compose in this case with a so we will have docker file. We see what's docker file, and we have Docker Compose also. And the server is the physical server that is used to host multiple virtual machines, so this layer remain the same. And the host operating system, if you try to compare that with the virtual machines, we have some differences. The server is the same, the host OS operating system is the base machine such as Linux, Windows, for example. So this layer is the same if we remember the different layer of virtual machines. And with a new generation of Docker engine. And with Docker, we have Docker engine. This is used to run the operating system, which earlier used to be virtual machines as Docker containers. And all application run as a Docker container. So this is, let's say, an overview about Docker architecture. We have more detailed about that. I really recommend to see the documentation of Docker to see more about the different layer in Docker architected. So when we talk about Docker or container in general, so we have two things to consider. So we have Docker containers, the container that we already create, and we have the image. Okay, so a Docker container in this case is virtualized runtime environment used in application development, and we are able to create, run, and deploy application. It's the definition of Docker that are isolated from the underlying hardware. So Docker container can use just one machine, share its kernel and virtualized operating system to run more isolated processes. So in this case, Docker container are lightweight. This is why we minimize the container always for security purpose. So it's lightweight. And what is the image? Today we will try to create an image, and we will start with a specific image to build and to run. Let's say we build the image and we will run a container. So Docker image is like snapshot in other types of virtual machine environments. It is a record of a Docker container at a specific point in time. And Docker images are also immutable. While they can be changed, they can be duplicated, shared, or deleted. The feature is useful for testing in new software or configurations because whatever happens, the image remains unchanged. And containers require the existing runnable image to exist. They are dependent on image because they are used to construct runtime environment and are needed to run an application. When we create our container, we see that we start with existing image. It can be one and more than image. In our case, for .NET, we will create ASP.NET, ASP.NET Core. We will start with two images, the SDK and the image of ASP. And we will create our image to be able to run our container, our first container. An image can be changed, and here we will talk after about the tags. It's like version. So the main step is taking an application from source code to run a container. We can see that here. So in this figure, we develop your application. We build the application and dependency into an image. You ship the image to a registry. So this is optional part because you can use your image internally to run your container. But if you create a new image, if you are inside an organization or company, whatever, So you will create a new image, and this image will be scanned. We have specific process, we call that hardening of the images. So you create specific image for developer team. You scan image to be sure that we don't have any vulnerabilities, and you will try to ship it in specific registry. Registry can be private registry, internal registry, and it can be a remote registry like Docker App, like Azure Container Service. We see the registry that is inside the different services inside Azure. And it can be another product. So Docker is integrated in multiple products. You are able to use other product like JFrog, Artifactory that can be used internally. We use other tools to scan your image automatically. So you try to make the process here. This is why I said the registry is an option here. So we build your image. Next, we will run it as a container. We run this image as a container. So the whole process is extremely simple. So we have two main steps to run an applications container. You package the application as an image and run it as a container. As you can see, it's really simple. So as you have the image, you can run it as a container. And we said before that you will create your own images. So the image is a collection of layers because we will use multiple other images, but we have different layers. We cover that after. Then compromise the application and in all dependencies. So it includes the runtime, it includes the different directory, the folder that I will access, the build part, the publish part. And the most common way to build an image is with a Dockerfile and Docker build command. If you have any questions, so you can ask me after in the end. So we will leave 5 minutes to ask different questions by chat. Now let's talk about the Dockerfile. What is Dockerfile? So we said that we have our image, we create our image, so we build our image, we have an application, we build your image, and we will run it as a container. And to build our image, we will create a file, we call it that Docker file. It's like a list of a structure tell you that tell Docker how to build the image. So it will include different lines, let's say different layers. It's like script composed of various commands and arguments listed successively to automatically perform actions on a base image in order to create or form a new one. Because we will start with existing image. All the image, they are all the, let's say, certified image, improved image. They are in Docker Hub. You can find all the images in Docker Hub website. And they are used for organizing things and greatly help with deployment by simplifying the process start to finish. Dockerfile will begin with defining an image from which the build process starts, followed by various other methods, commands, and arguments. It can be a conditions also, so you're free to do that also. But in return, as a result, provide a new image which to be used for creating Docker containers. And images are used to start one or more than containers because you can use the same image to start other containers. So if you're a developer, think of images and containers. It's similar like classes and objects. So we create containers from images in a similar way to creating objects from classes. If you are more of sysadmin or DevOps coming from this world, it may be helpful. Think of them as if you are a developer. Think of images container as similar to classes and objects. So we create containers from images in a similar way to creating objects from classes. If you are more now, let's. So this is an overview about how what's Dockerfile, how we build image, how we can run that. Let's take a look about the content of our Docker file, how it works. So the first thing we need to define, always we start by the from here command line. So we need to set a Docker a working directory here, as you can see, where we want the files to start to end up on the container. And we start by here in this case, we have used SDK, the first runtime that we need, that is the SDK of ASP.NET Core. This is a Docker file example of .NET 8. And if you check in Docker documentation, you can find other languages like Python, like Go, whatever. So, so this is let's say optimize it. Let's say optimize it Docker file. So we start this. We say optimize it because we include a specific feature here. So we have build part, we have the base publishing part. So, and here we start by specifying the image. Next, we need to copy the project file ending in .cs proj. Additionally, we also need to call .NET restore to ensure we install our specified dependency. After, we need to copy our application files and build your application. Here we specify again another image that we need, that is ASP.NET 8, and our working directory. And because we need SDK the runtime, and we need also the ASP.NET. And here we need to copy, as you can see, the content of the build on the another directory for publishing our application. It's a simple example. And to start the application, we need to add a specific command line, for example, to say that that's entry point. It takes an array that transform into a command line invocation with arguments. Transform that as .NET CLI after. And our command looks like here, for example, we said .NET and use the DLL of your application. After creating that, after creating your Docker file, you can create it manually, or you can generate it in Visual Studio also. You can generate it also some command lines of Docker. We will see that after. Next, we have to build and start container. So we use Docker build -t to give a name, -t, and we give a name here of our image, and we use this one as a tag. It can be one dev, whatever, one dot zero or dev or prod. So we give specific tags, and here -t to give a name. This is why we use it. For here to run. So even we build means create your own image, and from your own image you will create your container. This is why we use run. We said run. And here we have Docker run. It's really simple. -d just to run container in the background. It's optional, but it's better to use it in this case. -p means that we will match an external port with an internal port container. For some Docker file specification, you need to specify expose and internal port to force the use of the port, specific port. So, and it's not needed in our case to run it. For example, we will run it on 80, for example, here, and 84. And minus name is giving minus. See, this is two minus name. We need to give a name of application. Minus rm docker will remove the anonymous volumes associated with the container where the container is removed in this case. And this one, we need our image. So we use the name of image, and don't forget the tags. This is why we said we can create multiple container based on one image. So you can create another one with another name with the same image. So we can have multiple containers from the specific image that already created. So this is an example of Dockerfile. And sometimes we ask about why we need to use container, and we sometimes we said, okay, container is for microservices. No, you might want to use container just to simplify deployments, even if you are not creating your microservices. It's not dedicated to microservices. Microservice is a way, a specific style of architecting, and the container is a way of deploying any application. It's not only microservice. We know that comes with it's not really comes with microservices because we have multiple container means that we will deploy multiple services. In this case, we can be in another and not microservices only. So it can be APIs. We need to manage the communication. We can deployment after we manage the communication between them using orchestrator that will try to orchestrate between containers. So this is not about always microservices. So if you want to improve your DevOps workflow with containers, it's opportunity for you to isolate test environments from production environment, and in this case you can also eliminate deployment issues caused by missing dependency when you move to production environments. In case like this, even if you are deploying a monolithic application, it makes sense to use Docker and Windows this case. And for .NET framework, old one that's where it's only running on Windows operating system, you can use Windows container in this case. What are the common use case for container? We said web development. Container, it's really great show. So we can configure Docker container internally, use the Docker container internally. You install Docker Desktop. We see the prerequisites after what you need to do to start with containers because simple for you to deploy a variety of environments. You can deploy using a Windows machine to a container using Linux operating system because Docker Desktop allows you to deploy to select from Windows or Linux, and you are able to run your specific image and container in Windows, in Linux, for example, also. And we said also here, if you have existing or application, you'd like to modernize it before trying to mo- uh, before deploying it, let's say to create your microservice architecting. So you can just use a container also. You can do it for reals, refactoring steps, or for lift and shift to containers. So we add the Docker file in your application, and you using the specific runtime, you can check different line time and you can generate, as I said before, your file and send. You will see how we can generate it internally in Visual Studio Code, Visual Studio 2022. So we Docker supports, we can say here. But you can generate or you can create it manually, your Docker file, run your application as a container. So it's not in your monolithic application as a container. And here for re-architecting also microservices. So container are a good choice for microservices architected because they can be used to deploy and manage individual services. Continuous integration and delivery because we said that we can automate the processes for building, testing, and deploying applications. So it's a powerful tool that can be used to improve your application development, deployment, and management. Let's start by the demo, but before what we need to work our specific demo here, we need to install Docker Desktop. It's really free. I will show you how you can do that. It's available for Macintosh, for Windows, file for Linux also. We need a Docker app if you'd like to deploy to deploy your specific images inside the Docker app as private registry. You can use it, so you are able to. It's public private registry. It's free for to deploy. You have one private one, private registry, but it's a public registry. If you go through the pricing of Docker, you are able in this case to make a Docker app as a private one. It's not public. You can run your images in a private registry inside Docker app also. Uh, you need to install one. Today we will just see how we can use Visual Studio Code, but we can do this. It's more simple in Visual Studio. So user more user friendly user interface inside the Visual Studio. So will have a Docker support, and you can generate everything, and you can deploy in few clicks to you can run your application, and you can deploy it in the cloud also. To deploy in Azure containers services, we need to have at least an Azure account when we are able to at least to create Azure Container Registry or any other service related to container. Maybe we need sometimes, if you prefer using command lines, you can use or PowerShell or Azure Cloud Shell if you would like. It's up to you. So you can do that in terminal of Visual Studio Code, and you can just use your PowerShell, or uh, when you deploy your container in Azure, you can use Azure Cloud Shell. We need to add some extension. If you will We will use a Visual Studio Code, C Sharp, because we will create ASP.NET Core, so we need the extension of C Sharp to run Docker. And if you will deploy on Azure app services, that will allows you to deploy in one container. We see this service also as a container. We need an extension, the extension of that to be installed. So let's take a look here quickly in what we need here. We have Visual Studio, the editor. It's in French. Sorry for that. So, but try to do that. It's related to the machine in this case. Sorry for that. So, but it's here, Visual Studio. You can download it and install it. You have community, it's free. You don't need to install a professional enterprise. This is more for organization, for companies. Here, a big organization, for example, enterprise. And here we have Visual Studio Code. You can see here that's for we it can be installed in Windows, in Macintosh, Linux, so it's really simple to use. Here for Docker desktop is what we need. We will see how it looks like. We need to download for Windows, for example. In my case, I'm using Windows 11, and you can install it for Linux, Macintosh. You can see here you have multiple ship, for example, me ships here to install. And you need to create an account. It's here like similar to this one, to sign up, and you try to create your own app, or after you need to sign in, for example, in my case here, and you will have your own public registry. Here, for example, my own registries. I have a lot of registry, but if you'd like to create a specific registry and push in this registry, you see here one private for free. For free, it's free Docker, but you have other plans to consider as big organization, for example, companies that need to have it as a private registry. So here, one for the public, and all of the images will be public. And for private, so you need to go to have more than one. You need to go to the pricing part of Docker here. You have a different pricing here. Sorry, and this is the different pricing here. You can see related to the number of employees in a solution, related also to the specific features that you need. So here the different pricing, and for personal use, so it's simple, so it's free. And we have some other features that are added for personal use also. This is about the prerequisite here. And to start, we will build a Docker image. We'll try to tag this image. We see how we can add taggings. We remember the tags once, like versions inside. If you use a DevOps Git, for example, so it's like a specific version. We deploy in specific version, and we will build and store images in the cloud. For example, in our case, we try to see what is Azure Container Registry. It's really private registry. It's not public like Azure, like Docker app. And you can also we see how we can deploy also our images in Docker app. To start with, so here we will use Visual Studio Code, and it's really simple. I will open an empty repository in this case, and we will open the terminal to run to create, let's say, new application. It's .NET new web application minus O to give a name. This name my container, and I don't need to HTTPS in this case. And we'll try to go through my application because it's important to have a CD to go through your application to run uh, your specific command line to build and run your solution. So .NET build in this case. Next, we will see after .NET run to check our application. You see it here from the structure of our application. It's simple application. We have the different pages, and we don't have any Docker file internally. We will try to generate our Docker file. We see how we do that. So to do that, we now just we will try to run to see the our application. It's really simple here, simple application here to run it, and we have here the link to see our application with a specific URL, the specific port here. You see, so you know that, so it's a really generic one. Now let's try to generate our Docker file, but we need to have this extension of Docker already installed. You see here the container images and the specific recipe already configured here. We need to configure them. So to generate, you click on Control Shift P. You can use the extension. So as you can see, add Docker file to workspace. It's a way so you can generate it. You don't need to create your own Docker file. Else, we can go again to the terminal and use some command lines of Docker like Docker init. It allows you, it's really like automating things here that ask you some questions and will generate. So here it asks you what is your project, it's able to know what's the project, what's the name, which .NET frameworks, 8 for example, and next here you will see that we will generate a Docker file, and to come to build and run our application, we use Docker Compose app minus minus builds. If you remember before, we said that to build, we can create Docker builds, and this is Docker desktop. We will see just the image. We don't have any image. This is Docker desktop, but we needed to install it before starting this demo. So you see here it's empty one, and here we use Docker build for building Docker run, but you can use this command line. This is why I'm using this command line. It's more simple to build and run, create your image and run your application. This is the Docker file that already generated, you can see. And here it's simple one. You can see it's really optimized the Docker file. It's using Alpine as operating system, Linux operating system. It's recommended to use Alpine as operating system for .NET in this case. It's better than using Ubuntu for security purpose, but it depends from specific features, specific, let's say, your application. Here we have your image, and you see, we created already here in the image, and let's check the container. You see here, it's another. Here we have our container, and we have Docker Compose already in our machine, so it allows you to use also an application. You can see this is my application with that's running in another link with another port, means locally. And let's check now. So this is my application already created. And if we check here in images, we have latest, that is our tag. So we can see the tag is latest one is created by default. And you can add another tag like that. So it can be dev tag, for example. And this image will be also generating the same container. We can see here. It will run the same container because we didn't change in it's the same image, so it will be used also for the same container. Let's move now to uh, the next one is how to build image in container services inside Azure. To store your image, you need to use container registry. It allows you to create your own private Docker. It's like Docker app, and it offer you different benefits because it's a really private one. So we have highly scalable, providing enhanced throughput for Docker pools that can span many nodes concurrently. You can monitor your containers internally, so your images also. You can store and host images and build images. And before moving to the demo, next one, let's talk about the different other, let's say, different others container services. To start, we said that we will start on Azure Container Registry. If you use a monolithic application, you have two solutions, that is Azure Container Instance and Azure App Service as a container. And to use, if you have more than containers, you have multiple services or microservices, let's say, you can use Kubernetes, Azure Community Service. You know, Kubernetes is an open source orchestrator, the most used in the market, and you can use it. This service is really simple to use to orchestrate between your containers. Another product that is serverless one, that's Azure Container Apps, that allows you to also to orchestrate between different containers. And if we see here, to create, to build, you can use the Azure portal to create it from, you can create from the portal, you can create it from Visual Studio. After you can push from Visual Studio or VS Code. Let's check that. For example, if I have specific registry, not this one, for here. So here I have already configured my registry. I will check if we have already a specific uh, I have some problem here to access here. I have some problem access, but here, if you go to, let's come back here, you can create it here from create resource. You can create your own, maybe because I don't have any registry. You try to go here to containers, you check you have a different services for container, have a container instance, we have web application, it's related to one container. We have container app, is for orchestration. You have Kubernetes, a native one. This is related to Azure Arc, and you have Azure Kubernetes AKS here. And for a registry, just you create, you fill different information needed, you give a name to a registry, you select your resource group, location after you create your registry. Else, you can use command lines, feel free. You can use you as it SER, create, define your resource group, give a name, you select your pricing plan, let's say, and you try to enable the admin part if you will use the registry as an administrator. After to orchestrate in Azure Kubernetes Service, you need to enable admin enabled. You enable your administrator part for this registry. And we finish with another one, that is Azure Kubernetes Services. So it's managed Kubernetes service that lets you quickly deploy and manage clusters. It's really simple to use. It's for multiple containers. You can use command lines. You can use the portal to create your, if you remember, Azure Kubernetes Services, or command lines. And to deploy, it's really simple. You need to connect, you create a specific file after empty file, and you will add your deployment YAML file. This is an example of YAML file. Next, we need to use kubectl, is command line related to Kubernetes. To apply, you use your deployment YAML related to your application, and to check after it's, if you have any problems or no, you can check your you get service, you can see the services, you can check your kubectl get deployment. You have a different command lines to use, so the same command lines that you already use in native Kubernetes. And we have Azure Container Apps, that is a really fully managed environment. It's really serverless hosting service. We have specific AKS services that's already integrated. You are able to deploy containers, and the difference between them depends from the scenario, the application. So, but we need to know that's not exposing Kubernetes API. This is the difference between Azure Kubernetes Service and Azure Container Apps. I don't know if you have questions. Think we already. I will check the chat here. I don't know. Do you have any question here? And grazie. Thank you for joining me today. So hope you like the session. I will share the presentation in the end. You can reach me by Twitter, by LinkedIn, if you have any more questions here. And thank you for joining me today.